Buongiorno. My name is, no, guten Tag. My name is Roemer. My name is Roemer. I do the Io and Jupiter thing. When I first started talking about this, one of the reasons I gave for it being an absurdity is because Roemer was using a telescope, right? So, what we have is new chalk. Oh yeah. Right, I'll explain it for those of you that aren't too sure. Sun. We're going to put Jupiter so you can see Jupiter, right? It's there, right? And this is Io, right? And we have Earth here, and then it's going to move anti-clockwise. Hey mate.
Going for fish.
All right, bud.
Go.
Okay. All right.
Can I wear this thing?
Yeah. Don't get it all bait on it.
No, I'll take it off the
Oh, I can wash it anyway. All right, mate. Love you. Right. So it goes anti-clockwise, and he took readings from at its closest, from here, from here, from here, from here. When he was closest, he saw Io come out nice and early, and as he moved away, Io seemed to be delayed as it came out from behind Jupiter. But he was using a telescope, wasn't he? Let's just say, for example, that there was somebody here with a telescope, here, 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 and here, and they were all looking at Io and Jupiter at the same time as Roemer was when he was here. What do you think they would see? Do you think they would see a different image than what Roemer was seeing because they're further away? Think about it. Do you think that these people on twin planets in different positions around the sun, they all had the same telescope as Roemer and they were all focused in on that? What would they see? They would see the same thing, wouldn't they? Because they're all using telescopes. So why on earth would Roemer see any delay when he was doing it on his own? Because he's using a freaking telescope. So even if there was a delay, it's unbelievable. That right there just shows you how absurd it is. Now, there is always a chance, right? This is what I'm finding. This is what I'm finding. You have that info, a lot of you have this information now, but you cannot work it out. You don't know what it means. What do you mean, would the others see a light delay? This is where the trouble is. People are having trouble breaking this final fact down that proves it's an absurdity. It's like it's so obvious, right, that they're all going to see the same thing. So it wouldn't matter if you took a reading from there, 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 or there, or there. There would be no difference in any of Io's movements. It's that basic to work out, that one. But we're here now. So, let's listen. It's only 4 minutes.
The topic of the speed of light has been debated for many centuries and even millennia, until it was finally put to rest by Danish astronomer Ole Roemer in 1676. Before this, key historical figures had all sorts of ideas about how light traveled. Empedocles, for example, believed that light did travel at a finite velocity, but he didn't have any experimental evidence for it. Aristotle, on the other hand, disagreed. In his book Sense and Sensibilia, he said that light is due to the presence of something, but it is not a movement. Since speed is defined as a movement over a set period of time, the argument for a finite speed is pretty easily dismissed. Of course, this discourse happened over 2,000 years ago, and in more recent times, the great French philosopher and mathematician René Descartes.
Now, I'm always saying, they've invented people, they've thrown people, added them to the history books. They have. See how easy. Everything that, all of this stuff, right? Let's get this fucking board down. All of this stuff should be alright. You have to look at these things, but look at them and think. Put yourself up in the position of the people that are doing these things. If you don't do this, you'll never know. You know, I got myself, feel myself trying to quarry a stone out of a rock-faced wall. Until you do this stuff, right, you don't know what's involved. And if you don't know what's involved, you'll just take everything on face value and go, oh yeah, no, that was doable. I'm telling you what, no, it's not. Now this, please, come on. I need to do those really good knocks then. Oh, here we go. Guys, 60 seconds. I'm not going to get back. Don't die. Oh, the telescope. Whew. Right. Oh, and needed a phone. Oh. I'm not very organised, am I? Right. When I first got this down, some of the comments, right? One person, oh, look what this guy spends his time doing. There's something wrong with him. Something wrong with me. You tell me a better way to get a picture of stuff than a blackboard. It's just these comments like that, and it's like, it makes you realise how out of touch people are with learning and stuff, right? Roemer. This is when they were born. This is when they did their thing, their invention, their discovery, their absurdity. And this is when they died, right? Where are we? Olaus Roemer, 1644. Born in 1644, give or take a year. 1676 he did his thing. He was 32 years old, right? And well, we've already seen that it's an absurdity. It doesn't happen. But why on earth was somebody observing a planet that's at times close to 1 billion kilometers away from us, right? 3/4 of a billion to nearly 1 billion. And what made him look at this moon and pick out a light delay? That there isn't one. We know that, even during a solar eclipse. There is no light delay. It's just these absurdities, right? These people, they're just Christian Huygens, 1629, the wave theory of light. In 1674, electricity came into Europe, was properly established 1880, 200 years before electricity. And Christian Huygens came up with, what book is it? Hang on, shouldn't take long. Right. The date is 1674, somewhere, okay? This is Christian. Among Huygens' claims to fame was his research work in optics, and particularly in the wave theory of light. He presented this theory to the public in his Treatise on Light, 1690, but he had worked out its details long before. He held that the different points of a wave front or wave crest of light set up an infinitely numerous series of secondary waves. These secondary waves reinforce each other after a time and produce a new wave front. Other secondary waves arise, and these result ultimately in still another wave front. Thus, light is propagated. Now, how? What? Huh? 200 years before electricity, they've got nothing. Nothing. Oil wicks, candles, that kind of a thing, right? How on earth it's so stupid, right? You've got Olaus Roemer, who apparently detected a light delay, even though there is none, and with a telescope, even if there was, that would nullify it, wouldn't it? Because he's using a telescope, so he's always gonna see the same thing, isn't he? These things, right, honestly, telescope. The person who allegedly invented the telescope, look at this name, Hans Slipper, honestly, Galileo Galilei, that's an I, Galilei. I tell you what, someone is having a crack. Someone is laughing. Right, carry on with this. Listen to this absurdity.
Positive experimental proof for an infinite velocity of light, in response to an experiment done by Beekman in 1629. Galileo's idea...
Who? Beekman? That's one name. That...
and mathematician René Descartes' positive experimental proof for an infinite velocity of light, in response to an experiment done by Beekman in 1629. Galileo's idea to measure the speed of light was to have two lantern bearers standing a known distance apart. Once the first lantern bearer uncovered their lantern, the second would immediately uncover theirs as soon as he saw the light. Galileo tried this with an assistant across many months.
Another one. If Galileo was the person, was the scientist that they say he was, do you really think that he would have had to physically get two of his assistants and tell them to go one over there, and open your lantern doors, and I, with a pen or a pencil in the dark, because there's no electricity or anything, he's gonna somehow work out how long it takes? Can you not see how stupid this one is? Galileo, if he was the scientist that they say he was, he wouldn't have needed to tell two assistants to do that. It's common sense, isn't it? These things, right? Everywhere you look, people, you don't know how to put yourself into these people's positions and play out the role that they're playing. Empathy, right? And you put yourself in their position and close your eyes and go, fuck no, right? Roemer, looking at Jupiter and Io. I've been out there in the last 12 months, or the last 24 months, 4-5 times, right? Physically put myself there thinking, right, I've got no power, no timekeeping devices. How on earth? It's until you put yourself in the physical shoes of the person that they're talking about, you do not know how ridiculous these things are.
But naturally could not make out any time delay and only came to the conclusion that light is at least 10 times faster than sound. Everything changed when Roemer got involved, but he wasn't even trying to measure the speed of light. During his time, the technology required to accurately determine the time at longitude 0 did not and would not exist until British horologist John Harrison developed his chronometer in 1761. Roemer was going off
No.
of Galileo's suggestion that the tables of the orbital motion of Jupiter's moons could provide a clock in the sky, with each individual eclipse representing the tick of a hand. Navigators and map makers anywhere could use this clock to read the standard time at a place of known longitude, like the Paris Observatory where Roemer was working at. Roemer decided to focus on the moon Io as it was the closest to Jupiter and therefore had the smallest period known now to be 1.769 Earth days. An eclipse happened every orbit, which Roemer timed for several years. However, he noticed something unexpected. As Earth moved closer to Jupiter in its orbit, the time interval between consecutive eclipses became shorter, and it became longer as Earth moved further away from Jupiter. He realized that this would make sense if light had a finite velocity, as it would have to cover extra distance in order to reach Earth from Jupiter when it was on the other side of the Sun. After all, sunlight reflecting off of Io's surface is what allowed Roemer to make his observations in the first place.
Relativity is bullshit, right? This right here, Roemer, is your first little nudge at a light delay. It's almost like he's just giving, humanity a nudge. Hey, relativity's coming. Look, I discovered this in 1776. Rubbish!
Based on the accumulation of the time differences, Roemer was able to estimate that the eclipse would occur 11 minutes before it was predicted when Earth was at its closest to Jupiter, and 11 minutes after it was predicted when Earth was...
But he was using a telescope, so how would there be any difference? He's using a telescope. It doesn't matter where we would be in our orbit around the sun. If he's using a telescope, there's never going to be a delay, because it's going to be, honestly,
furthest away from Jupiter. All that was left to do was to take this extra distance equal to the orbital diameter of the Earth, or twice the astronomical unit, and divide it by 22 minutes. This arithmetic was not carried out by Roemer, but rather a Dutch physicist by the name of Christian Huygens. His calculation yielded a value equal to 131,000 miles per second, which is about 70% of the true value. This 30% difference was because of some errors with Roemer's estimation of the map.
see? They love to, oh, it was close, but, or this, or the reason that they, it's just, can you not see that they know fucking everything? It's ridiculous. Everything down to the very last detail. They have everything covered. Everything covered. It's ridiculous.
Maximum time delay, which should have been 16.7 minutes rather than 22, along with the inexact knowledge of the astronomical unit, which we now know to be exactly 149,597,870,700 meters. But what matters is that this was the first quantitative measurement of the speed of light that was not too far off from the true value, and conclusive evidence that it
Not too far off from the true value. Good skills back in those days, I must say so.
is indeed finite. The true value of the speed of light has been used to define the standard unit of length, the meter, as the distance a photon can travel in exactly 1/209.
Photon. But during solar eclipse, right, when the sun is directly behind the moon, there are no photons involved. If you cannot see by now the absurdities, right, the lies, it's unbelievable. It's almost bordering insanity, isn't it? I think it's hilarious.
9,792,458 of a second. The experiment is reproducible and can be carried out by anyone as technology has improved vastly since Roemer's time, and the
Someone go and measure the speed of light. Measure the speed of light radiating from the sun. It is not a measurable quantity. It cannot be done. And anybody who says it does, or it can be, do it and film yourself doing it.
arithmetic isn't very difficult at all, especially now that we have calculators. High-quality telescopes can be purchased anywhere for very little, but the most difficult part would probably be replicating his sheer dedication to the project, collecting data for years. Although it didn't help any navigators at sea due to the motion of the...
So you can get a telescope and stuff, but you really would have to show some dedication to take notes over years. Anybody who had a really, really good telescope, right, and who started to observe Jupiter and Io, or Europa, or Ganymede, or the other one, there would never be a light delay. There would never be a change in the time any of those moons swung out from behind Jupiter. Never. Because there just is no delay. The sun's light bangs up onto Jupiter and Io at absolute speed. There is no delay. If the sun went out and you were looking at Jupiter, everything would go black at the same time. It would go dark, boom, everywhere, from here to past beyond Pluto, at absolute speed. Slam dunk. There's no doubt.
Both being magnified tremendously by any telescope should only
There can be no light without a source.
patch of the sky regardless. It did, however, prove to be useful in determining the longitude of islands and ports while on land, and of course ended a debate that spanned across millennia. And for that,
you stop it. Another one. We're here. So, 1849, right? It said that he bounced a light. That's what they say, a light. 8 Ks one way, bounced off of a mirror and travelled 8 Ks back and slid safe through the teeth of a spinning wheel. 30 years before electricity. What kind of light was that? Honestly, where is it? Fizeau experiment. Is that the one that I was on about? I think it is. It's only 5 second ad. Ta-da! Boom, boom, boom.
Important that the width of the teeth are exactly the same as
No. Don't mind. Bit of early curry. I sometimes have trouble understanding this guy.
It's the 19th century and we want to find the speed of light. For this setup, we will need a motorized rotating wheel which has a large number of teeth and gaps like a carrot.
This is not the one. Roemer. Right, hang on. Here we go. Whew. Right. Now, listen to this horseradish.
In 1849, a French physicist named Antonio Louis Fizeau did measure the speed of light.
No, he didn't.
As Galileo had done, Fizeau chose 2 high points, but in his case, they were a good deal further apart, at just over 8.5 kilometers. In place of covering and uncovering lanterns, he used shiny light through the edge of a toothed wheel. Whether the light beam got through the edge of the wheel depended on the wheel's position. If one of the gaps was in front of the light beam, it got through. If one of the teeth was in front of the light beam, it was blocked. To avoid the problem of human reaction time, Fizeau placed a mirror on the far hill instead of a person. He also added a partially reflected mirror to guide returning light to his eye. When Fizeau set the wheel spinning at slow speed, a flash of light.
Now, he sent a beam of light 8 kilometers one way and 8 kilometers back, right? You heard. Now, I've got this one. No, let's just use the red one. 8 kilometers, this is 30 years before electricity, okay folks? 30 years before electricity. Where did that laser go? Why am I having so much trouble with this laser? 1849, 1880, that's when electricity was established, probably in Europe. What kind of, see this laser? Now, how would I go bouncing this 8 kilometers in one direction, hitting a mirror and having it come back precisely in between the teeth of a spinning wheel? How would I go? I've seen them try it nowadays, right? Here we are once again. How on earth, before electricity, did Fitzhugh manage to bounce a beam 8 k's one way off of them? If you cannot see, once again, what you have to do is go and try this stuff yourself. It's no good just reading the Mickey Mouse-ness and believing everything. The reason that I scream and shout is because I've played all of these out. If I haven't put myself physically in their shoes to play it out, I've done it with just about everything. That's why I know that it's all bullshit. And there are too many of them. There are too many of them, right? Joseph Lagrange, 1772. The James Webb Space Telescope is hovering on Lagrange point 2, right? Joseph Lagrange worked this out in 1772, 100 years before electricity. How on earth, what on earth is going on? How did this guy, 100 years before electricity, work out gravitational pulls, 2 objects, right? That a third one can hitch a free ride because of the push and pull of the other 2, right? It creates a dead zone of gravity and it freewheels. 1772. Huygens and Olaus Roemer, 1600s. 200 years before electricity, coming up with speed of light stuff. Kepi, Johannes Kepler, holy smokes, 1609. He's working out planetary motions, elliptical orbits and stuff. How's he doing this in 1609? 300 years before electricity, or 280 years before something. These things, right? Do you not say to yourselves, why were all these people doing all of this stuff? And we're talking, I don't count Copernicus for some reason. It starts at Galileo, Italy, Denmark, Germany. What's that? I'm not even sure. France, Netherlands, Holland, Italy, France. Now, there was no telephones, there was no cars, no trains. Why is it this all happened? Something in the water in Europe maybe, right? And all of these people, you know something? All of these people, between them, sorted just about everything that was needed for this. You know that? Just about everything that was needed. It's one hell of a coincidence, isn't it? I think it is anyway. It's so...
It shot through
silly.
one of the gaps, would travel to the mirror on the distant hilltop, get reflected, and travel back to Fitzhugh so fast that the gap was still in place.
Oh.
The wheel had not had time to move a tooth in the way of the beam of light to block its return. Fitzhugh then increased the speed of the wheel until light moving through each gap of the mirror and back encountered a tooth instead of the gap on its return. This blocked the light from getting to his eye. Fitzhugh continued to make the wheel spin faster until eventually the light would shoot through a gap, and by the time it traveled to the mirror and back, the tooth had moved completely across the line of sight. The beam of light returned just in time to move through the next gap,
Hey!
and he could see it again. In super slow motion, it would look like this. Knowing the number of teeth and the rotation rate, Fizeau could calculate the
See, this is what they do, right? I said it to somebody and they went, no, those are the numbers. I said, no, they're not. They say
time it took for one tooth
Fizeau
to move out of the
knew.
way of the returning light. Dividing the distance by the time gave him the speed of light at 300.
Fizeau knew the speed and the how many teeth, yada yada. Therefore, was able to work out the speed of light. So what was that? Do that equation for us. Show us, physically work it out, step by step, right? How fast was it going? And then what do you do with that number? What you do? And what do you get? And then what do you do with that too? It never happens. They never actually break it down because they can't, because it's horse shit. Honestly, this is why they get away with stuff, because nobody looks right into it. They don't ever give a proper breakdown and explanation of it's always, and because he knew this and he knew that, he was then able to work out the speed of light. Honestly, it's one big
13 million
cluster.
meters per second. He was only off by 4%.
And there it is again. He was only off by 4%, which was remarkable. A remarkable achievement for so long ago. So long before light and electricity. It's just the horseradish. We need to open a horseradish supply chain because it's like the magic porridge pot. Half an hour. All right, peeps. I'll be back.